Hello, welcome to Coffee Break with Microchip Technology. Coffee Break is our ongoing series of live stream events in which we talk about new and evolving technology, all in about the amount of time it takes to drink a cup of coffee or a cup of tea. Today we're kicking off Season 8 of Coffee Break. We'll be airing episodes every 2 weeks, starting today and finishing up in the middle of December. I'm your host, Eric Glatfelter. Joining us today in the booth to manage the logistics of the live stream event is Aliyah Fahout. Aliyah, welcome back, and would you describe for our audience how they can interact with us today?
Okay, thank you, Eric. Well, thanks for being here today. Good morning and good evening to everyone. We are currently live on YouTube, Facebook, and LinkedIn. You can participate in today's episode by leaving your questions and comments in the chat or emailing us at livestream@microchip.com. Don't forget to follow, like, and subscribe to all our social media platforms. Thank you. Back to you, Eric.
Great. Thanks, Aliyah. On to our topic today, bare metal coating on AVR microcontrollers. Joining us in the studio today is Ross Satchel, Technical Marketing Engineer here at Microchip. Ross, welcome to the program.
Thanks, Eric.
All right. Before we dive into the actual topic, for our audience today, who should care about bare metal programming?
Good question. So the people who should be focused on bare metal programming are those who are trying to reduce their code space or even to have their code run faster because they can have far more efficient code.
Okay. So when I hear the term bare metal, I think about mask layers or manufacturing processes. So can you just dive in and tell us what is bare metal programming or bare metal coding and where did that originate?
Sure. So bare metal means that the instructions are carried out directly on the hardware registers, which means there's no abstraction layers. To put that into perspective, one extreme end of abstraction layers is Arduino, where you have an API that you use, but you don't actually directly use the underlying hardware. And so as a result, since we're working on the hardware registers, bare metal programming is also known as register level programming. And so the registers are just memory locations. We can read from them, we can write to them. And at this level of programming, our primary references are the device datasheet and also the header files.
Okay. That sounds fairly complex. So what kind of tools do we have available for people to learn more about this in detail?
So we have a tech brief to really make the learning curve much gentler. Because previously bare metal had a very, very steep learning curve. So in the old days, that's the early to mid 90s, we used opcodes where everything was in hex, where you had a register base address and a register offset. You would have to calculate your register absolute address and then write or read to that register. Everything was in hex and it was very difficult to write, read, and also debug. So then assembler came along, which simplified everything, and then later on C code, which made everything much easier. But even when we started using C code, we were still using bit shifting or hex values, which are often referred to as magic numbers, because you would have to convert to binary, see which bits are flipping in the registers, and there's still opportunities for simple errors to be introduced. And so it's still kind of difficult to make it to write, read, and debug. But using this tech brief, TB3262, makes that learning curve much gentler because it lays out the structures of the registers in the microcontroller. It also shows you how the datasheet registers are reflected in the header file because they match exactly as they're written. And then finally, it shows you how to use the macros that are defined in the device header file to make your coding easier and also far more human readable.
Okay. Can you tell us a little bit more about the macros?
Sure. So with the macros, they're simply listed as a module name. So for example, timer counter A is listed as TCA, and then you'll have the register name, and so it might be control A, and then the bit field or bit mask, that your individual bit that you're writing to, and then just the setting that you're using. So you can directly read it off from the data sheet and the setting that you want. And the great thing about this is that the code is the comment. So as everybody learns fairly early on when they're programming, is that often either the comment is wrong in the first place or someone has changed the code and they haven't updated the comment. And so then it can be quite misleading and you go chasing down a rabbit hole and you can't figure out what's wrong. In this case, the code is the comment and all you need is a single comment for what this block of code does because you can see the individual lines and they're very human readable. You know exactly what's going on.
All right, so to clear, make sure I'm hearing this correctly, there is no separate comment field.
Correct. Yeah, there's no individual line comments.
Okay.
There's just this block of code does this thing, and then you just read it off and go, that makes sense.
Great. Okay. Now, if somebody wants to actually learn how to do all this, what do we have for them? Where can they go?
So go to microchip.com and you can just search for TB, as in Tech Brief 3262, and it's getting started with writing C code for AVR microcontrollers. And it goes through and walks you through exactly how to do this, from setting up your clock to setting up individual registers, how to use group masks to clear bit fields, how to use group configurations to write bit fields, bit masks for individual bits. It's really well laid out and easy to read, easy to follow.
Okay. And then we have online courses as well, right? Or video tutorials.
Correct. So we have a video series that we currently have 6 episodes available currently on Microchip Developer Help. And the playlist is called Intro to Bare Metal Programming with the AVR Tiny 2. And we have more episodes in the pipeline. And so it's going to culminate with a project that actually uses 2 Tiny 2 Curiosity Nanos, where the first one is in low power mode. You press a button to wake it up, it'll turn on its LED, take an analog to digital converter or ADC read, and then send that over SPI to the other microcontroller. It will then turn off its LED and go back to sleep. The second Curiosity Nano will go from low power mode, pick up the SPI data, wake up, send the data over UART to the terminal in a human readable format, and then it will return to sleep. So it's a fairly complex little project, but showing just how powerful bare metal programming is and actually how easy it is to do.
Okay. So somebody has gone through all this. They like the approach and the idea. They've learned how to do it. They implement this. What ultimately are the benefits going to be to the designer and or the project that they design?
Sure. So first of all, you have more compact code. So you can, as I said before, you can clear bit fields with group masks, and you can also write bit fields with group configurations. But it also means it's much easier to maintain. Because when you want to change the bit field configuration, you just change the mask name. You're not doing individual bit shifts, you're not doing hex magic numbers, and so you don't need to change each bit value.
Right.
And you're also impervious to driver updates, because you've written the driver and you can read exactly what's going on, and any updates that happen don't affect you. You also get to know the device intimately. So you get to improve your skill set, and as a result, you can create your own driver set and keep your own Git repo, and so you can test all of the edge and corner cases, and you can have bulletproof drivers.
All right. Wow, fascinating topic. Thanks, Ross, for giving us an overview of that and sharing that. Aaliyah, do we have questions from the audience yet?
Yes, I do have a question for you that we received via email. So how much data and program space can you save doing bare metal?
Sure. So this is a good one. So it really depends. So taking the extreme end of ease of use with what I call the Arduino Blinky, which is the hello world of the embedded systems, where you blink an LED. To do that with an Arduino, you're looking at 924 bytes. Now, if you use the same device, that's the ATmega 328P, doing bare metal, and also using the Arduino IDE. So the only thing that's changing is the code that you're writing. You're looking at 144 bytes. So we're talking about more than 1/6 savings. So that is, your bare metal code is 1/6 the size of the Arduino code. And so this could mean in your larger application, this could be the difference between using a less expensive part that has a lower amount of memory, or having to redesign your whole project using a more expensive part with more memory. Now, MCC Melody is more efficient than Arduino, but it's still a little bit less effective than bare metal. And of course, people will make the comparison of, well, okay, assembler is more efficient than bare metal. And while that's true, the user has to figure out what amount of time and then, of course, cost investment they're willing to do for their code size savings. So of course, in engineering, everything is a trade-off.
Okay, great. Well, the second question I have for you is from YouTube, and it is how to choose between PIC 8-bit and AVR 8-bit MCU.
Well, it really depends what you're trying to do. You need to make sure that the microcontroller has the peripheral set that you're looking for, and if you're new to this, then you need to make sure that it has the drivers for the peripherals, etc. But the main thing is making sure that your clock domain is taken care of and all the peripherals that you're looking for are taken care of.
Perfect. And I have another one from you from YouTube. Does the MCC allow me to code for the AVRs?
Yes, it does. It does. MCC and specifically XC8 compiler allows you to code both PIC and AVR microcontrollers inside MPLAB X.
Thank you, Ross. I also have another question for you. Are there bare metal series on PICs available?
There is one that's just been started to be developed now, so we're hoping to have the first episodes of that within a few weeks.
All right, great. And are there other tech briefs available for using peripherals?
Yes. So you can search microchip.com for the Getting Started With series. So it covers getting started with USART, then ADC, timer counter A, timer counter B, event system, and a whole bunch more. So you can go to microchip.com and you can either directly search for them in the search bar, or you can go to Tools and Resources, Documentation, App Notes to search for them there.
Well, thank you, Ross. Let me see if we have any more questions for you today. It looks like those are the only questions I have for you. So thank you, Ross.
Thanks, Alia.
Again, you can email your questions and comments after the broadcast at livestream@microchip.com. And thank you again. Back to you, Eric.
Right. Thank you so much, Aaliyah. Ross, thank you so much for joining us. It's
Thank
a
you.
fascinating topic. To our audience, thank you for your time. If you're curious about this topic, please view the documents that Ross had mentioned or the YouTube playlist. If you like the series, please visit us at microchip.com/coffeebreak. There you can see the posted episodes for our upcoming Season 8, as I mentioned, running every other week now through the middle of December. You can also see our previously recorded sessions. There's a wide variety of topics that you can play the recorded sessions. And you can also register for notifications and add episodes to your calendar to be sure that you don't miss them. Thank you again for your time. See you next time.